All right, guys. So I received a few questions about 78 that I think could help everyone. Um, Number one, for example, right? If we're gonna use separation of variables, the first thing we got to do here is we would basically multiply both sides by dx. So if I take it one step at a time, I would have something like this. Let me switch to blue here. I would have something like this. Let's see. I would divide both sides. Well, one step at a time. Multiply both sides times dx, and then divide both sides by y squared, excuse me. So I would end up with 1 over y squared dy is equal to x dx. Now, of course, this is going to be y to the negative 2. So remember, this is not going to be the natural log. Some of you probably think that, but it's not. And then now we're going to go ahead and just integrate that, all right? So we're going to add 1 to the power, divide by the same. On this side, I would have an x squared over 2 plus c. So this is negative 1 over y is equal to x squared over 2 plus c. Now, you could try to solve for y here because we are trying to solve for f of x, which is y. But before I do that, I'm going to go ahead and plug in those points, all right? And by that point, I mean this. So I'm going to plug in a 1 for y and a 1 for x. And that's going to give me a negative 1 is equal to 1/2 plus c. So c is equal to negative 3/2. Now, after I plug that back in, okay, I would end up with negative 1 over y is equal to x squared over 2 minus 3 over 2, which I can then rewrite as, since this is the same denominator, I can rewrite it like that. Now, to get the answer that I have, all right, you can do two things. Remember, I'm solving for y. So you could, if you wanted to, since you have a single fraction on the left and a single fraction on the right, you could cross multiply and solve for y. And or what you could also do is to realize that you have 1 over y. So if you have 1 over y, you could just flip both sides, the equation on the left and the equation on the right. And I'm using my hands a lot as I do this, and I realize you can't really see my hands. So, very animated here. All right, and then now I don't want to have negative y. I want to have a positive y, correct? So if I multiply both sides times a negative, I would have a y is equal to a negative 2. Now remember, you can make the top part a negative or the bottom part a negative. It doesn't matter which one you use, but this would be the final answer, right? So, all right, so let's go on to number 4, which kind of starts this. A few of the problems are kind of the same, all right, in a lot of ways, where they follow this right here. But even if you didn't know that, you would get to it, right? So even if you didn't know that that's what it was leading to, you would get that regardless if you know how to do this. So let me look at my key real fast, make sure I'm doing the right thing here. I am. Okay, so now, first, we're going to start off by, a lot of the times, guys, like I've told you in the past, the hardest thing is to realize what this is asking for, right? So it says at each point, xy in a curve, the slope of the curve is 4xy, which means that this 4xy is the derivative, right? Which I'm calling dy dx. If the curve contains a 0.04, find its equation, all right? So what we're trying to look for is f of x. So essentially, it's like problem number 1, except for a little bit more complicated, but let's just get to it, all right? So we're going to multiply both sides times dx, and at the same time, we're going to divide by y. So if I do that, I'm going to have like 1 over y. Oop, that looks like a 4. dy is equal to the integral of 4x dx. And then now we're going to integrate that. Now the antiderivative 1 over y, remember 1 over y is the same thing as y to the negative 1. is the natural log, all right? So please don't forget that. That's kind of the important thing about this. So this is going to be the natural log of the absolute value of y is equal to 4x squared over 2, right? Because remember, add 1 to the power, divide by the same. That would leave me with 2x squared plus c. Okay, so now they're going to give us the 0.04, and they want us to find the equation. Now, at this point, you do have a choice, and either one you choose, you still get the same answer. So you can choose to go ahead and plug in the 0.04, and then after that, then you solve for y, which is fine, all right? But you could also just simplify this, because right now what I have is the natural log of y, and I'm looking just for y. So I'm gonna get rid of this natural log by using this e exponent, all right? I don't know how would you call that. Exponentiate, maybe that's a word. Maybe it's not. I don't know. Yeah, somebody who knows the English language better than I do. All right, so this is going to be e to the power of 2x squared plus c. Now, this is a part that you really need to pay attention because a lot of kids get lost. Now, I could rewrite this as 2x squared times e to the c. Now, why? Now, remember, c represents a constant. And e to the c, this part right here, is just a constant, okay? Now, what allows me to write it like that, remember, is a rule of exponents. So I'm going to give you an example here, but don't write it down because you don't really need to. Remember that if I had something like x squared times x to the fifth, this is the same thing as x to the power of 2 plus 5. So essentially, I'm going from this side and going to the left, okay? So that's how that works. So that's what allows me to call this e to the c. Now, e to the c is just another constant, okay? So I am able to write e to the c as just a constant. All right, so again, what happened here is that I replaced this e to the c with this value of c. Okay, so now, if it was asking me for the general solution of the differential equation, then I would be done, except for this one. It says that the curve contains the 0.04. So now I'm going to go ahead and plug in the 0.04. So I'm going to plug in a 4 for y, and I'm going to plug in a 0 for x. Now this is going to be e to the 0 power, which is 1. So c is equal to 4. So my final answer is going to be y is equal to 4 e to the power of 2x squared. And that's it. All right, so let's go on. So the next few more or less work out like that, okay? Even the one that has the cosine, it doesn't matter. Let's look at number 7, because number 7, something interesting happens to that one. Okay, so first, notice that it's the same basically problem that I had on number 4. They give me the slope, which is dy dx. Remember, that's the derivative. And it says find the general equation of the curve. So on this one, notice they don't give you a point. All right, so meaning that I'm going to solve for y, and I'm just going to leave it at that. It's going to have a c value in it, okay? So now we're going to use separation of variables. So when you do that, remember, I'm going to multiply both sides times dx. So it's going to leave me with 2y x dx. All right, now I'm going to divide both sides by d. When I just noticed I wrote a dx here, I meant to put a dy. I'm going to multiply both sides times, let's see, I'm going to divide both sides by 2y first. So this would be 1 over 2y dy. Now the x, I'm going to leave it alone. That's going to stay here because I need it on the right side, okay? So this would be 1 over x dx. All right. Now, before I go too far into it, I will pull the 1/2 out. So remember, any constant that's outside the integral, you can pull it out. And then now I'm going to integrate. So this is going to be 1/2. Now 1 over y, the antiderivative of that is the natural log of the absolute value of y. And the integral 1 over x is going to be the natural log of the absolute value of x plus c. All right. And now technically, yes, like I've said in the video before, there should be a plus c here, but by the time you bring it over, then that's just another constant, right? If I have a constant minus a constant, meaning I don't know what those numbers are, then I'm just going to get another constant. So this is why we normally don't ever write a plus c on the left side. All right. So now, since I am solving for y, I'm going to go ahead and multiply both sides times 2. So now I have the natural log of y. And again, there's definitely at least a couple of ways that I can think of solving for this, okay? Now, the next thing that I want to do here is I'm going to use one of the rules of logarithms, one of the properties, I should say, of logarithms that allows me to have if I have a number in front of the logarithm, I can bring it up as a power, okay? So I'm going to rewrite this as the natural log of the absolute value of y is equal to the natural log of x squared. Notice that I did drop the absolute value because x squared, any number that I pick for x is going to be positive by the time I square it, okay? So here I am. So now the next thing is I'm going to exponentiate both sides, or I'm going to use E, Euler's number. So this side now I have y. On this side, I can't get rid of the natural log. Okay, and a lot of you are salivating at the chance of doing that, but you can't. You cannot eliminate it because I have this plus c here. So it doesn't work like that. I need to find a way to get rid of that. Now, if this was a free response, guys, I would honestly leave it right here, all right? Especially since as we're getting closer to the AP exam. Now, because of the answer that I gave you, if this was a multiple choice and this answer does not appear on there, then what you have to do is a couple of things, right? Just like the problem before, this right here, I can rewrite that as e to the natural log of x squared times e to the c. So I replace the plus c with an e to the c. Now this right here would be y is equal to c e to the natural log of x squared. Now I can go ahead and cancel the natural log. All right, so this right here is what I'm talking about. I'm going to go ahead and this right here inverses of one another. So that's going to leave me with just the x squared. And that's the final answer. All right, last but not least, I'll probably do a little bit of this last problem here, the one with the square root. And then again, if you have any more questions beyond what I'm doing here, make sure to contact me through Remind. Or if you see me, I guess you can ask me then. Although I doubt you'll see me. But if you see me. All right, so now we have this a little bit more straightforward. We're just finding f of x. All right, which means we're solving the differential equation. So let's see, we're going to divide both sides by y. We're going to multiply both sides times dx. So that's going to leave us a 1 over 2 square roots of x dx. And then now I'm going to take the antiderivative. Well, before I do that, I'm going to simplify just a little bit. And sure, this is a step you could have done before I even did this, okay? So this is 1 over the square root of x. Now remember, the square root of x, or 1 over the square root of x, is the same thing as x to the negative 1/2. So please remember that. All right, so this right here is going to be the natural log of the absolute value of y. This right here, if I integrate this, if I add 1 to the power, I would have a 1/2. And if I divide by 1/2, is the same thing as multiplying by 2. I was about to write dx. That would be incorrect. So this right here is the natural log of the absolute value of y is equal to x to the 1/2 plus c. All right, and then now I'm going to plug in those points. Let's see. Oh, well. And at this point, you can go several different ways here, or at least a couple of ways that I can think of, maybe not several. But I'm going to go ahead and solve for y first, okay? Which is f of x. So I'm going to use e like I've used before, the past two problems. So it's going to be y is equal to ex to the 1/2 power plus c. Now, by the same reasoning, I can replace that c with an e to the c, which means that this is equal to c e x to the 1/2 power. Now, I'm going to plug in that 1 and that 4. So y is 1, x is 4. And I'm going to solve for c, okay? So we have e to the second. Now, so c is equal to 1 over e to the second. Now, the answer that I gave you, I believe, was, let's see, e to the power of x to the 1/2 over e squared, which is what you're going to get here, right? So again, I'm going to plug this right here. I'm going to plug it in right here, okay? So when I do that, I should get e to the power of x to the 1/2 over e squared, which you could also write this as x to the 1/2 minus 2 by the rules of exponentials, right? When I divide, I can subtract the powers. All right, guys, that's pretty much it. I hope that helped. And if you have any questions, please contact me.